Welcome to the YouTube channel PCMB Tutorials. I hope you all are fine. Today we are going to learn class 9th physics chapter work power energy, and this is part 11. In this part we have to learn whole thing about kinetic energy. Kinetic energy. So, have you ever thrown a stone against a glass window? If you do so, what will happen? So as the stone hits the glass, it breaks into pieces. Why does a glass breaks into pieces? So when you throw the stone, it sets into motion, acquiring some velocity. As a result, some energy is stored by the moving body, that is stone. This energy results in breaking of the window. When the stone strikes it, there the body possesses a result of its motion. The body possesses energy as the result of its motion. This energy is called kinetic energy. Kinetic energy can be defined as energy possessed by an object by virtue of its motion. I'll write energy possessed by an object by an object by its virtue by virtue of its motion. Its motion. Now, there are some examples of kinetic energy. Kinetic energy possessed by a moving bicycle. Kinetic energy possessed by running water from a river. Kinetic energy possessed by shooting arrow. Kinetic energy possessed by blowing wind. Kinetic energy possessed by swimming fish in water. Energy possessed by spinning electron around the nucleus. So why is kinetic energy so called? Because kinetic energy is derived from Greek words kinesis, which means motion, and energia, which means active work. Therefore, the term kinetic energy means through motion do active work. The terms kinetic energy and work and their present scientific meanings date back to the mid 19th century. Early understandings of this scientific meanings of these ideas can be attributed to Gaspard Gustave Coriolis, who in 1829 published the paper titled Du calcul de l'effet des machines outlining the mathematics of kinetic energy. Now, there are three types of kinetic energy. First is vibrational energy. Second type is rotational energy. Rotational energy. And third type is translational energy. translational energy. Now let us consider some examples to understand it. First is kinetic energy and mass. Suppose a tennis ball and an iron ball are thrown towards you with the same velocity. Which one is easier to catch? It is obvious that the tennis ball is easier to catch as it has less impact on the hand compared to the iron ball. This implies that kinetic energy possessed by tennis ball is less than that of iron ball. Conclusion is that kinetic energy of a body depends on its mass. So kinetic energy depends on mass of the body. The more the mass of the body, the greater its kinetic energy. The kinetic energy and velocity. Now consider the case 2 of stones A and B, the same mass hitting a glass window. Let the velocity of A be VA and be greater than the velocity of ball B, that is VB. Now VA is greater than VB, velocity of ball A is greater than velocity of ball B. Then the impact of the stone A would be much greater than the impact of B on a glass window. This implies that kinetic energy possessed by B is less than that of the A. An object moving faster possesses more kinetic energy than the object moving slower. This is solution to the questions. Now conclusion is that kinetic energy of a body depends on the velocity of a body. The more the velocity of a body, the more its kinetic energy. Kinetic energy of a body depends both on mass and velocity. Now mathematical expression for kinetic energy. Now consider a body of mass m at rest. M at rest. When a force is applied, it sets into motion and acquires the velocity after traveling a distance of s. Acquires the velocity after traveling a distance of s. This is velocity. And it was at rest means u is equal to 0. Now we know force is equal to ma, where a is the acceleration of the body. In this case, kinetic energy is measured by the amount of work done by the force to acquire the velocity. So kinetic energy is equal to force into displacement. Force into displacement. Force is ma and displacement is s. We know that v square minus u square is equal to 2as. We have to find this s, so we know according to the kinematics formula, that is v square minus u square is equal to 2as, means a would be equal to v square minus u square upon 2s. According to this, now the kinetic energy would be equal to mass into acceleration. We found v square minus u square upon 2s into s as it is, this s. From from this we got that kinetic energy would be equal to mv square by 2, or we can write this also half into mv square. So this is the first formula of kinetic energy. We can find kinetic energy by this formula, that is half into mass into velocity square. Thus the kinetic energy of a body is equal to the half the product of its mass and square of the velocity of the body. Likewise, momentum we will study now. Momentum like this, represented like this, P is equal to mass into velocity, mv. So kinetic energy is equal to half mv square. So kinetic energy is equal to half mv square. So on multiplying and dividing m by in the RHS of equation, that is kinetic energy is equal to half into v square, we will get kinetic energy is equal to m square into v square upon 2m. So from here we got that m square v square upon 2m is equal to kinetic energy. After all the solvation, we got kinetic energy is equal to p square by 2m. This is the second formula. Kinetic energy is equal to p square by 2m. Also, momentum p square is equal to 2mk. This k is kinetic energy. And if we have to find the p is equal to root of 2mk. Like this. This is known as the kinetic energy. I hope you've understood till this. In part 12, we will solve questions based on kinetic energy. There are many questions, we will solve them. I hope you've understood till this. Thank you for watching. For any queries and doubt, please join the Telegram link given in the description of this video. Like this is the foundation of class 9th. We have covered the foundation of class 8th and 7th too. The links are given in the description. Thank you for watching.